Good afternoon. In this talk, I want to introduce you to Koura and its role in the fluorinated materials supply chain and the work we've been doing with E-Lyte to develop new fluorinated materials for batteries. It will be a joint presentation with me presenting the first half and then Collier Beltram of E-Lyte presenting the second half. I will begin by introducing you to Koura before moving on to discuss the importance of fluorine to batteries and then share with you some of Koura's views on the impact the expected growth in demand for batteries will have on the fluorine supply chain. I will then outline details of Koura's work in this area before handing over to Collier, who will take you through the work Koura and E-Lyte have been doing together developing new products based on some of Koura's new fluorinated materials. Koura is part of the Orbia group of companies whose products touch all of our lives. Orbia is probably one of the biggest companies you've never heard of, but it has operations in 62 countries, commercial activity in 121 countries, 22,000 employees, 121 production plants and 19 R&D labs. These are all spread across 5 major business units. Building and infrastructure, which supplies innovative and durable solutions to the construction industry. Data communications, which provides the products that connect people. Precision agriculture, which allows more to be grown with less. Polymer solutions, which provide specialty PVC-based formulations to a wide variety of industries, including construction, automotive, consumer goods, and medical. And Fluor, which provides fluorine-based products, technologies, and other materials that support modern living. Koura's history goes back to ICI, which led the fluorochemical industry's response to the Montreal Protocol. Koura is still at the forefront of developing sustainable fluorine-containing products and the processes to make them, which includes new low GWP refrigerant blends and medical propellants for the treatment of respiratory illnesses, as well as new and existing materials for energy storage. Today, Koura are the only fully integrated fluorochemical producer outside of China, or as we like to call it, operating from mine to market. Our key assets are our fluorspar reserves and mines in Mexico. The picture on the right of this slide is of the mine in San Luis Potosi, which is the largest known single deposit of fluorspar, and which is an output almost 3 times larger than the next biggest mine. What is unique about these fluorspar deposits is the very high calcium fluoride content, which makes processing much easier. In total, Koura own 1/8 of the world's fluorine, but the reality is that for various reasons, many of the other known reserves are not accessible. For example, they are too remote or they are too dilute, which means that Koura and China effectively control about 50% each of the accessible reserves. Nearly all of the Chinese fluorspar is consumed within China, and it is disappearing fast. Some estimates say that it will be gone within 10 years. So Koura is as vital to the fluorine supply chain as the Middle East is to oil supply. Koura is a global company. In addition to its mines in Mexico, has fluorochemical production units across the globe and an R&D centre in the UK. Nearly half the world's fluorine is used to make fluoropolymers and refrigerants. The bulk of the rest is used in aluminium and steel production, and then a small amount is used for pharmaceuticals and agrochemicals. Lithium-ion batteries currently account for around 2% of fluorine demand. Fluorinated materials are most commonly found in the battery electrolyte, the salt, the solvent and the additive, but also in the binder materials, where they make a vital contribution to cell safety and performance. Indeed, some lithium-ion cells contain more fluorine than lithium. So if anyone is interested in finding out more about the benefits fluorine brings to batteries, I suggest they start by reading Martin Winter's excellent review. Batteries, and lithium-ion batteries in particular, have moved to the forefront of global policies designed to tackle climate change. So demand for batteries will grow, driven by key applications such as vehicle electrification. This growth will put strain on the supply chain for all key minerals, including the usual suspects cobalt, nickel and lithium, but we should not forget fluorine. By Koura's estimates, battery-driven demand for fluorine is predicted to grow to 30% of world production by 2040. But, as we've already discussed, fluorine is a major component of many key products. Demand for these products is not going to disappear and will in some cases grow as well. So by Koura's estimates, the growth in demand for fluorine driven by batteries could lead to a supply-demand imbalance from 2035 onwards. But if anything, the widespread adoption of EVs seems to be moving forward, and so it is credible that fluorine supply could become tight in this decade. So Koura's fluorine is a key element in the immediate future of batteries. But remember, it is one thing mining the fluorspar and quite another converting it via hydrogen fluoride to key products such as lithium hexafluorophosphate and the binder PVDF. These figures show quite startling growth in demand from batteries for PVDF and lithium hexafluorophosphate, but we're almost out of date as soon as we produce them, because in September 2020, Tesla announced plans to reach 3 terawatt-hours of battery production by 2030. Now, in this scenario, growth for these two products is starting to look exponential, and who would bet against Tesla from achieving this target? So extra capacity in the whole fluorine chain were needed, from fluorspar mining, HF production to finished products such as salts, solvents, additives and binders. Figuring out the supply-demand imbalances for PVDF is quite difficult, but relatively easy for electrolyte. The EU market for electrolyte is estimated to be 300 kilotons per year by 2025, but only 130 kilotons a year of capacity has so far been announced, leaving a gap of 170 kilotons. 300 kilotons a year of electrolyte roughly equates to an additional 66 kilotons a year of fluorspar mining and processing for the EU alone by 2025, and for just one fluorine-containing product, lithium hexafluorophosphate. So not surprisingly then, the widespread adoption of batteries represents a transformative opportunity for Koura, firmly founded in its very tangible fluorspar assets in Mexico and positioned as one of the very few fully integrated fluorochemicals producers, which of course is an excellent strategic fit as Koura continues to evolve from a raw materials provider to a solution provider. I want to now introduce you to our work with E-Lyte, with whom we have been developing and testing new fluorinated materials and incorporating them into fully formulated high-performance electrolytes. To do this, Koura is leveraging its expertise in fluorine chemistry and fluorochemical production to develop new battery-relevant compounds based on accessible chemistry and feedstocks. To date, we've prepared many new compounds in a wide variety of relevant compound classes, such as ethers, acyl carbonate esters, with potential applications of new conducting salts, solvents and additives, and started testing them with E-Lyte.
Andy, thank you very much for introducing Koura to our audience and for showing us the importance of fluorinated chemicals for an application in batteries, and also for giving us insights into the fluorine market. So ladies and gentlemen, welcome to the second part of our presentation today. So my name is Kolja Beltrop from E-Lyte Innovations, and we are dedicated to the development and production of tailor-made electrolytes for energy storage systems. In my presentation today, I want to highlight the importance of tailor-made electrolytes for especially lithium-ion batteries. But first of all, I want to introduce you to our business units. So at E-Lyte, we have the electrolyte manufacturing as business unit 1. This is, of course, the production of ready-to-use electrolyte solutions. So this could be based on standard recipes, a well-known 1 molar LiP of 6, EC-EMC 3x7, for instance, but also advanced electrolyte formulations based on our know-how regarding or targeting special applications, special cell chemistries, only to mention a few. So in this business unit, we are very flexible with packaging sizes. So we can deliver 100 grams, for instance, also up to 2 kg bottle sizes, but also larger volumes, 20 kg barrels, and in the very near future, also 200 kg barrels. And of course, as a battery chemist, we know about the importance of high quality. So this is what we are also aiming for in this business unit 1. So business unit 2 is the electrolyte development. And there, of course, we work very closely together with our customer on their specific pain points. So this could be, for instance, a cell manufacturer, where we try to find the best electrolyte solution for a special cell chemistry or a special application, for instance, low temperature or high temperature performance. But also we are working with customers who want to introduce their products into the battery market. And a perfect example, of course, we see later on in the collaboration work with Koura, where we try to put their chemicals into an electrolyte formulation to address different applications. The business unit 3, of course, is measurement and consulting. So there we are talking about feasibility studies, benchmarking studies, but also physical and electrochemical measurements on electrolyte and also cell level. Ladies and gentlemen, the electrolyte in a lithium-ion battery is a key component, and one can call the electrolyte as heart blood of every battery. So as we humans need the blood to survive, every battery needs the electrolyte to survive. The electrolyte is a multi-component system, so we have a lithium salt, typically the LiPF6 dissolved in a mixture of cyclic and linear carbonates. This is a so-called mixed solvent approach, where we try to marriage advantages of both substance classes. So on the one hand side, the high dielectric solvents, the cyclic carbonates, together with the low viscosity solvents, the linear carbonates, in order to get a very low viscous system. Furthermore, we have some performance additives in order to tailor special properties of our electrolyte regarding or targeting special applications. Okay, I want to now focus on the working principle of the lithium-ion battery to make the importance of the electrolyte to the system even more clearer. So at the charge, first charge, the lithium ions are located in the positive electrode material and migrate through the negative electrode. So the first function, of course, for the electrolyte is to act as a highway for lithium ions. But more important, or maybe equal important, is that we have to have the formation of passivating surface layer. So this is on the one hand side the very prominent SEI, the solid electrolyte interface on the negative electrode, and also the CEI, the cathode electrolyte interface on the positive electrode. Without these interfaces, the electrolyte would not be able, the battery would not be able to survive. Yeah, and these interfaces are mainly composed of electrolyte decomposition products, which are not soluble in the electrolyte. So they precipitate on the surface of our active materials and protect the bulk electrolyte from further decomposition. So therefore, a tailoring of the electrolyte is very important and is a key for us to tailor also or to target different application fields of our batteries. Okay, so as I said, electrolyte as multi-component system, we have direct influence on key performance indicators such as energy, power, cost, lifetime, and safety of the final lithium-ion battery. And when we now take a look on the effect of the fluorination of the electrolyte, it becomes also clear that we can tailor oxidative stability, so we can increase the oxidative stability of our electrolyte. This is important when we think about higher cutoff voltages. We can tailor the SEI formation, as I said, and fluorine is in some applications very beneficial to have it in the SEI. We can increase the wetting ability of our electrolyte. We can increase lifetime and safety. Yeah, ladies and gentlemen, now we are coming to selected lithium-ion battery markets and needs. And yeah, I show you here, yeah, in principle, the three most common and most discussed battery markets. So this is on the one hand side, the electric mobility, the consumer electronics, where everything starts with, when we think about Sony, yeah, in 1990, and of course energy storage. And there, of course, we face different requirements for each battery. So we have high energy density, or the need for high energy density. We have a high rate, or we need high rate performance, and of course reliability and safety. And yeah, on the next slides, I will show you some recent results we obtained together with Koura, and I want to show you results targeting these different fields of application. The overall goal, of course, and this is for, I think, for every battery researcher, is that we will reduce the global CO2 footprint. Okay, coming now to the first results I would like to show you. So the influence of fluorination on safety, and therefore I want to show you on the right-hand side a table containing flashpoint values, and the lower one is containing self-extinguishing time values. So of course the first one you would like to increase, so You can dramatically increase the flash point by using fluorinated solvents. And of course, you can decrease the self-extinguishing time also by fluorinated solvents. So this is actually well known. However, it is important that these molecules are also acting in a good way together with the other electrolyte ingredients. And there, of course, we can see a significant reduction, and this for sure means an increase in safety. Yeah, the other application targets silicon anodes. So this is a very hot topic in the community. We want to increase the capacity on the negative electrode side. We want to substitute graphite in order to increase energy density. However, we have to face some issues there. The big volume expansion of silicon leads to ongoing consumption of lithium ions, and this is, of course, the reason for this fast cell fading or capacity fading. This is also something which we can improve by using adapted electrolytes. And in this example, we use fluorinated electrolytes from Koura, or compounds from Koura, which we introduce in the right way to existing electrolytes. And what you can easily see is that we can increase coulombic efficiency and also cycle life. Yeah, another hot topic in the community for sure, this is the so-called holy grail is lithium metal. Yeah, so by introducing lithium metal, of course, we can increase energy density, but also there we are facing big issues when it comes to the unhomogeneous decomposition or plating of lithium metal on lithium metal. So this comes along with the dendrite formation, of course, a big safety issue. So what we are performing here, we did lithium stripping and plating in a 3-electrode setup, and we monitored the evolution of the overpotential. And the reference electrode is well known to the community. So this is a mixture of a linear and a cyclic ether. And you can see that the increase in overpotentials starting at maybe 200 hours here in red is very dramatic. And by changing the cyclic ether to a Koura compound, we can drastically improve this. And some recent results also show that this combination is very suitable for lithium sulfur cells. So we have recent results obtained actually this week that we can increase, as I said, coulombic efficiency, increase lifetime. We can decrease solubility of polysulfides in the electrolyte. So also this is very promising. Yeah, as I said in the working principle of the lithium-ion battery, we are also focusing on SEI additives because I showed the importance of these additives to the field and to the lithium-ion battery. And there, of course, I would like to show you one of our patents. So we patented or we applied for a patent with the carbonate derivate, which is substituted with the nitrogen atom. And the rest here, of course, gives us multiple possibilities to substitute, and also, for instance, with fluorine-containing compounds. So on the right-hand side, you see in principle the proof of concept. And I want to highlight this. This is actually really a proof of concept because we use an electrolyte formulation which does not work without any SEI additive. Okay, PC is well known to lead to ongoing graphite exfoliation. Yeah, and by using different SEI additives, we can basically compare our new technology to the standard technology. So the VC, the FEC is very well known. And what you can easily see is by introducing our molecule, we can increase discharge capacity, energy density, and also lifetime. So based on this work, we did some further work in another cell chemistry. So here we are, or I'm talking about graphite LFP cells, where we also introduced our molecule to weight %. We compared to VC. We did some electrochemical impedance spectroscopy measurements. And what becomes clear is that we can decrease internal resistance. This gap is even more dramatic when we go to low temperature. So what I want to point out here for special application is low temperature performance, but we are also focusing on high charge rate. Yeah, so fast charging, of course, when you think about electric mobility, this is also the goal, to get the battery charged in a very short time. Yeah, ladies and gentlemen, I hope that I could show you some promising results, that Andy and me were able to show you that the fluorination of electrolyte molecules is very important. So in principle, to sum up, so Koura has secure access to fluorine and its compounds. It's a fully integrated provider of fluorine-containing products. And of course, and this is very important, Koura is leveraging its expertise in fluorine chemistry to develop new processes and products. And what is E-Lyte doing, of course, is that we have the technological know-how to develop new electrolytes for batteries in a wide range of application. So I showed you some of them: safety, high temperature, low temperature, high energy density, of course, high charge rates, and many more. Yeah, and E-Lyte has state-of-the-art infrastructure to produce and tailor these newly developed electrolytes in really shortest time. Thank you very much for listening, and I would like to welcome you at E-Lyte and also at Koura. And if you have any questions, please contact us. Thank you.